Obviously, we made flashcards, so that means you have to memorize them. Ew.
Chemical formulas for all of these.
When I say carbonate, you have to know that it's CO3 with a 2- charge. Yeah.
Okay.
I know. There's a little trick though. Still kind of sucks.
I mean, you can memorize the pairs pretty easily.
Mm-hmm.
But
Yeah, there's a trick I'll show you.
I mean, all of them include oxygen molecules.
Yeah. There's two that don't.
There's two that don't. Okay.
These two don't. But
I'm
yeah.
talking about pairs.
Oh yeah, the pairs. They do.
And then all of them.
Yeah.
When you go to fate, like it's like the 3 and the 2 goes down to 1.
And
Yep.
And then, yeah.
So
and
from
then
4 to 3.
nitrogen
3 to 2.
sulfur includes the element as well.
Uh-huh.
So
really all you have to do is figure out the charge.
Yeah.
Then. Yeah.
And all the pairs, I believe, are negative.
Correct.
That's easier.
Easier. Good. All right, this is as far as we got last time with the notes. Talked about ionic bonding. We did homework 4.1 where we were putting together the two, like the positive charge and the negative charge. Leanne, when you get a second, can you turn off the lights? So we use the columns on the periodic table to figure out most things. Magnesium, fluorine, put them together. We needed 2 fluorines to counteract 1 magnesium. Magnesium fluoride, the ending changed to IDE. IDE is the suffix that you get when you pulled something directly off of the periodic table and turned it into an ion. The ones that we just did on like the card here, like phosphate or phosphite, ate and ite imply that you should have them memorized and don't look them up on the periodic table because it's a molecule with a charge instead of just a single element. So if a regular atom turns into an ion, then you use the periodic table to figure out the charge. If a molecule, instead of a single atom, has an ionic charge now, we just have to memorize it, and that's why we made the note cards. Most of the time, if you don't know the charge, you just have to like Google it. But the ones that I gave you on the flashcards are like the most common 15 or however many, 12, 13. They're the most common ones that you see over and over and over and over and over and over and over again. These are called polyatomic ions. Poly, many, atomic, atom, many atoms together are molecules. I don't know why they don't just call them molecular ions, but polyatomic ions is what we went with instead. No. Did you run out of paper? Because I still have like a bunch of paper.
No, I have paper.
Oh, yeah, I was gonna do 3 examples down below.
Okay.
So variation of what we were doing last time, instead of sodium chloride, what if I wanted you to give me the formula for sodium flashcard sulfate? Or calcium phosphate, or aluminum hydroxide. The first part, sodium, you can just look up from the periodic table. What's the charge on a sodium according to our little cheat sheet way? If you have your regular, get out your regular periodic table, because we'll just mark it up so that way it's on there and you don't have to like reference the homework every single time. But the columns were, this one is the 1+ column, 2+, 3+, 3-, 2-, 1-, none. So sodium is in the 1+ column. So here's sodium. Sodium sulfate, Na+1. Sulfate, I have to flip through my little cards because I just barely got them like 15 minutes ago and I don't know any of them. I got it. Nope.
Sulfate.
That's
I was thinking of another example.
okay. So sodium and then sulfate here, SO4, 2-. SO4 is the molecule. It's a sulfur with 4 oxygens attached to it, and the whole molecule has a charge of -2. So this part, I know it seems excessive to write this, but once we get halfway through the unit and you've got a lot more molecules on your plate, it'll be nice to know like where we got these from. So this is from the periodic table. And this you had to look up from your flashcards. And we're going to put them together. We're going to put them together in the same way. Sodium in the front with a little box for how many of them we're going to need. Sulfate with a little box for how many of them we're going to need. The sodium is 1 positive, the sulfate is 2 negative. So how many sodiums do I need to negate 1 of those? 2. 2 sodiums to negate 1 of the sulfates. And then there's a couple different ways you can write it. You can leave it as it is. Na2 parentheses SO4 1. You can take out the 1. I would probably just write it like this. Calcium phosphite. Calcium is just a regular element from the periodic table, so I find it here. Calcium 2+. Phosphite PO3 3-. In most cases, it really is as simple as just moving the numbers from one side to the other here. Most of the time it works. So calcium phosphite 2 and 3 can go into 6. I can just use the little trick here. I'll need 3 calciums, 2 phosphites, Ca3, PO3, 2. You should leave it this way. Sometimes students want to do this thing where they like distribute and then they have calcium 3, 2 phosphoruses, and 6 oxygens. Don't do that. This makes me sad. Hello. Hi. All right, so while I get Lavi and stuff, yeah, we got new, it's everyone here. While I get them some flashcards and stuff, try the aluminum hydroxide. They did it. So just sit there and contemplate why you're such an overachiever. Again, I was gonna distribute it, but I'm not gonna. Just leave it with the little parentheses and everything still intact. Don't distribute. All right, I don't think it's too bad. It's just the same thing as last time. We're adding, instead of individual atoms, we've got molecules. So here's homework 4.2. And this is how they actually look instead of just the formula that we wrote. Like you have to draw a little picture showing their attachments and such. For example, hydroxide on the flashcard, we wrote just OH minus. But here on the picture, we've got an O and an H. They're connected. And then the whole thing, it's a little bit difficult to see, but the whole thing has a minus charge. The acetate has 2 carbons, 3 hydrogens that didn't print very well, 2 oxygens, and the whole thing has a minus charge. So your turn, just to try and draw these out. Carbonate, CO3 2 minus, super easy. The carbon in the middle. For now, we're going with like uber simple pictures. So just 1 carbon, 3 oxygens. The whole thing has a 2 minus charge. Ammonium is strange. It's the only one, double check your flashcard that you didn't mess this up on accident. It's the only one that has a positive charge. All of the other ones have negative charges. So that one is easy to mess up on. So there's the first part, pretty easy. You're just drawing the pictures and trying to learn the differences between all of them, get them in your brain, trying to get them memorized. Yeah.
How do you know what order you put the letters in? Like for the third one, how do you choose like?
This one?
memorizing?
You don't have to know the picture. You just have to know this. Good question. I don't like this method of learning it, but there is a way you can Google. It's called Nick the Camel. I know. It's called Nick the Camel, and let me show you like kind of how it works. It talks about Nick the Camel, and he goes and eats like clams or something. It's an acronym. And the idea is that you're trying to learn all of these ions, and the number of vowels that you have versus the number of consonants that you have is the ion. So for Nick the Camel, if you're trying to figure out nitrate, the N is from Nick. How many consonants are in Nick? 3. So that's how many oxygens you have. Then how many vowels? 1 minus. So like from this, you could figure out nitrate. I don't like it.
Yeah, that's dumb.
And then like camel would be carbonate, because you've got the C for camel, C for carbon. Consonants, vowels. Yeah. I don't like it. I would rather just memorize it, but if you're interested, there's something about Nick the Camel eating clams in Phoenix. I don't know. Look it up if you can. Okay, cool. Backside. This is the part that I most care about. This is where we start to put them together to form compounds. So a calcium is Ca2+, a chlorine is 1-. This is what we did last time. We did a swap on the charges. CaCl2 would be calcium chloride. Calcium with a 2+ charge, let me zoom in. Calcium 2+, oxide, I'd better look that up on the periodic table, IDE. So oxygen has a, let me look, 2- charge. So oxygen 2-. 1 calcium is required to match 1 oxygen. CaO. Making it more complicated by throwing in this stuff from today, like hydroxide, OH-, calcium hydroxide. I know that I need obviously a calcium. Putting a box there for how many. I'll put the hydroxide after. I'll need 1 calcium. And 2 hydroxides. Aluminum carbonate. Two aluminums. Three carbonate. So this chart's going to take you a little bit. This is the bulk of the assignment. Down below is just a reference of like more and more that you might have heard of, but you do not need to memorize these ones. These ones down here are just for reference only. You don't need to learn any new ones other than what we put in the flashcards, like permanganate. Might have heard of it, maybe not. Who cares? You're not using it right now. But I'm just showing you there's like thousands of polyatomic ions. You only need to learn the 15 or so that I gave you. Be careful with ammonium. This is the one that has that positive charge. NH4, 4 hydrogens, 1 nitrogen, and that positive charge on the outside. All right, before I let you work on this on your own for a bit, I will help you with the 2 questions on the front if you'd like, but any questions on the chart? Hey, work with a neighbor, double check yourself before you double wreck yourself. So yeah, of course, you don't have to do it like I am. You can just write it in like more normal style. So obviously, yes, you have to do number 2, but that's easy because you're just drawing bubbles. But down here, if you were asked to go to the chemical storage area and retrieve just a bottle of sulfate, sulfate is SO4 with a 2- charge, could you do so? Explain, assume that you have permission to, like, you know, go randomly grab chemicals. And what it's asking is it possible to have a bunch of just negative charges all together in one bottle?
No.
And the answer would be no. You'd have to get like something else with it. All of these are combined together. You have to have 1 positive, 1 negative. So your answer should say something in your explanation, like, no, you can't just have a bottle of all negatives or all anions. You'd have to get calcium sulfate or sodium sulfate. Something else positive would have to go with it. When asked to classify sodium acetate as either ionic or covalent compound, you haven't learned this one yet. This is the one that we've been working on. And this is what we're going to do next time. The student responded that sodium acetate was both. Explain why the student gave that answer. So ionic compounds are the ones we've worked with so far. It's based on opposite charges attracting each other. Covalent, new stuff, is going to be where the atoms share electrons with each other. So in sodium acetate, the sodium has a charge. The acetate, CH3COO. The acetate has a charge. So on the one hand, it is ionic because there are ions. But what you haven't learned yet that I'm explaining so you get the right answer is that this part is held together covalently. And this part here is held together ionically. When there's charges involved, it's ions. And Wednesday, we'll learn how they share electrons. That's going to be a different type of bonding.